Hi everyone, in today's video we're going to discuss the normal curve. So I'd like you to take out a piece of paper and pause the video and write down these notes and then hit resume when you're ready for the explanation. Okay, so this picture is a normal curve. So if you notice, it looks like this bell shape, and it has a line going down the center, and that line going down the center represents the mean. And there are two symbols that we use for mean: X with the bar on top of it, which you're used to already. And then this little Greek symbol, it's actually called mu. So that also represents the mean. So data is considered normally distributed if the mean, median, and mode are the same number. It's right here smack in the middle. So what that means is that there's symmetry about the center. Approximately 50% of the values are less than the mean and 50% are greater than the mean, which makes this bell-shaped curve. There are some other important notes about the bell curve. Approximately 68% of the data values are within one standard deviation of the mean. So if our middle is our mean, which is the X bar or the mu, then this plus 1 is one standard deviation. So sigma x, remember from previous videos, those mean standard deviation. So we have the mean and standard deviations above and below the mean. The negatives mean below the mean, positives mean above. So approximately 68% of the values are within one standard deviation of the mean. 95% of the values are within two standard deviations of the mean, and approximately 99.7% of the values are within three standard deviations of the mean. Okay, so next we have z-score. So if you want to, again, pause the video and write down this information and then hit resume when you're ready for the explanation. So a z-score is a number that represents the number of standard deviations that a data value is from the mean. This number can either be positive or negative. Like we discussed before, negative means data values that are below the mean, and positive means data values that are above the mean. So here's an example. Data is analyzed from the May SAT. It is found that the data values are normally distributed with a mean score of 1,000 and a standard deviation of 100. So basically what you want to do for every time you have a normal distribution problem, anytime you see the words normally distributed, you want to draw this line across your paper like I have here, and then you want to draw a sketch of a bell curve. Now the sketch doesn't have to be perfect, but it has to resemble some sort of symmetry around this middle section. So I'm going to use mu for mean, and I'm going to label 1, 2, 3, and then I'm going to label -1, -2, -3. So what these are our z-scores, the 1, the 2, and the 3, the -1, the -2, and the -3. So if you want to label that, you absolutely can. So we can call these the z-scores. And what's also important to know is that since this mean is in the middle between -1 and 0, the mean also has a z-score of 0. So it's important to know that as well. So what I'd like to do now with this picture, I'd like to put the information down that we have. Since we have a mean of 1,000, I'm going to take 1,000 and put it in the mean spot. And since it says it has a standard deviation of 100, that means every one that I go over, I'm going to either add 100 or subtract 100. So this would be 1,100, 1,200, and 1,300. And if we subtract 100 going back in the left, this would be 900, 800, and 700. So I could ask you questions like, if a person scored a 1,300 on the test, what is their z-score? You would tell me 3. If a person scored a 900, what is their z-score? That answer would be a -1. So every time you have a normal distribution problem, you're going to have it broken down into two things. it's either going to give you a data value, so we'll call this the data, the information that's given, and then we have to correspond it to a z-score. So 1,100 data value corresponds to a z-score of 1. And this is kind of the process. So I know it's a little bit new still, so let's go through one more problem to see if it makes more sense. So again, if you'd like, pause the video, write this down, and then resume when you're ready to continue. So it says if a person got a 1200 on the exam, what would be their corresponding z-score? So I want to draw that picture one more time. Now I know you're probably going to get sick of drawing the picture, but the picture is the most important part. So we're going to draw it, and we're going to put our mean, which was 1,000, and our standard deviation of 100. So I'm going to label this one as 1,100, 1,200, and 1,300. And I'm going to just keep going back, 900, 800, 700. So the question is saying, if a person got a 1200 on the exam, what is their corresponding z-score? Well, if I just did here, these are my data values in blue, we can underneath it put our z-score. So we know the mean is always a z-score of 0, 1, 2, 3, -1, -2, -3. So these values here are our z-scores. So if a person got a 1200, well, let's take a look over here. 1200 has a z-score of 2. So that means that the 1200 is 2 standard deviations above the mean. So a positive z-score means we are above the mean. All right, let's try another problem. So same thing, they want to know if a person got a 915 on the exam, what is their corresponding z-score? So let's draw the picture one more time. And we're going to put our mean right in the middle of 1,000, 1,100, 1,200, and 1,300. Then we have 900, 800, and 700. And if we want to put the z-scores underneath, the mean is always 0, 1, 2, and 3, -1, -2, and -3. So if a person got a 915, well, I'm looking at all my scores, and a 915 is not really an exact z-score. I mean, I can estimate based on a number line. A 915 would be somewhere around here, right? It's obviously greater than 900, but smaller than 1,000. So the answer we know for the z-score, because they're asking for the z-score, the red here is the z-scores, would be in between these two. So our answer we know is going to be in between -1 and 0. So we just have to figure out exactly what that would be. And there's a formula to find a z-score. So if I want to find a z-score that doesn't exactly match up, evenly, like 700, 800, 900, or anything like that, it would be the data value minus the mean over the standard deviation. And as an abbreviation, I like to say data value is dv minus mu, which is your mean, over sigma x as their standard deviation. Okay? So I want to translate this data value of 915. So that's why I've kept every single time I'm making the distinction between which ones are the data values and which ones are the z-scores, right? The z-scores are here in red and the data values are up here in blue. So if I want to find this z-score, I'm going to take the data value that I want to find, which is 915, I'm going to subtract the mean, which is 1,000, right? The mean I can get from here, the middle number. So data value 915 minus the mean of 1,000 all over the standard deviation, which is 100. So take a minute, pause the video, type that into the calculator, and hit resume when you get the answer. Okay, so my answer was negative 0.85. So my z-score is negative 0.85. And to be completely honest, that makes a lot of sense, right? If this is the mean of 0 and negative 1 is a data value of 900, 915 is about negative 0.85, and that makes sense, and that's how we find it. All right, let's try one more example. Okay, so still same situation. So we're going to draw another picture. We have our bell curve. My mean is still 1,000. 1,100, 1,200, and 1,300. 900, 800, and then 700. So the question is asking now, if a person got a 1,120 on the exam, what is their corresponding z-score? So again, with the z-scores, the 0 is the mean, 1, 2, and 3, negative 1, negative 2, and negative 3. So again, these red numbers here are my z-scores, and the blue numbers on top are my corresponding data values. Okay, so I would like to figure out what an 1120 on the exam would be. So let's think. 1120 is going to be somewhere in here, right? This would be about 1120. And we want to figure out what that z-score would be. So we're going to use the formula. So to find the z-score, we're going to take the data value that we want to find the z-score of, minus mu, which is your mean, over sigma x, which is your standard deviation. So my data value that I want is 1120 minus the mean, which is 1,000, over the standard deviation of 100. So take a minute, type that into your calculator, and then hit resume when you're ready for the answer. Okay, so I got 1.2. So my final answer for what is the z-score is 1.2. Now let's just check to see that makes sense. So we're at 1 and 2. Obviously between 1 and 2, 1.2 would work. 1.5 would be 1150, right? If we do it evenly. So that makes sense, 1.2. Perfect. Okay, so I'd actually like you to try this one on your own, and then hit resume when you're ready for the answer. Okay, so it says that the heights of the NBA players are normally distributed with a mean of 72 and a standard deviation of 3. So the first question is saying, if a player is 75 inches tall, what is his corresponding z-score? So I think I need to just draw a picture first. So I have my line with my curve, and in the middle I put the mean. So the mean is 72, and a standard deviation of 3. So what that means, a standard deviation of 3 is every one standard deviation to the right and every one standard deviation to the left, I'm going to add 3. So I'm going to add 3 to the 72, and I get 75. Then add 3 to that, and I get 78. Add 3, and I get 81. And then when you go to the left side, we do 72 minus 3, which is 69. Minus 3 again is 66. And minus 3 one more time is 63. So these are your data values. And you have your z-scores underneath it. So the mean is 0, 1, 2, and 3. Negative 1, negative 2, and negative 3. So now that you have everything set up, we can go ahead and answer the questions. So the first question says, if a player is 75 inches tall, what is his z-score? So 75 is exactly 1 z-score. So this person has a z-score of 1. 1 standard deviation above the mean. Okay. Then it says if a player is 70 inches tall, what is his corresponding z-score? Well, -1 is approximately 69 inches, so we're going to have to do a little bit of calculation. It's not exact. So our formula for z-score is dv, data value, minus the mean, mu, over standard deviation, sigma x. So my data value for this one is, I want to find exactly 70, right? So data value is 70 minus the mean is 72 over the standard deviation of 3, right? Standard deviation of 3 inches. So take a minute, pause the video, type that into the calculator, and hit resume when you're ready for the answer. Okay, I got a repeating decimal. I got approximately -0.666 or -6 repeated. When you get a repeating decimal like that, it's totally okay to just make it a fraction, and you can make it -2/3, or you could round the decimal and say approximately 0.67, would be the z-score. And I mean, that totally makes sense, right? Between 0 and -1 is 0.67. Oh, excuse me, -0.67. And that should be your final answer. All right, try out those problem sets, and if you have any questions, please let me know. Have a good night.